Okay guys, so let's go through this. Again, we have f of x divided by g of x. So we have x minus 2 divided by x squared minus 5x plus 6. First step, factor. And just be careful because we have to multiply to a positive 6. So we can't have a negative and a positive. We need two negatives because we need to add to a negative. Okay, so x minus 3 and x minus 2 should do it. And before I cancel out, what should I state? Restrictions. Okay, remember we can't divide by 0. That's where restrictions come from. So it's only what's in the denominator. So here x cannot equal positive 3 and positive 2. Okay, can we cancel out any like terms? X minus 2, x minus 2. So are we left with x minus 3?
Yes.
No.
No.
No. Okay. Anything divided by itself is 1. So there's 1 in the numerator and x minus 3 in the denominator. Okay, so just be careful with that. It's an easy mistake. Let's make it now, not on your quiz tomorrow. Okay, so next question, very similar, but instead of straight factoring into the binomials, we're going to factor by decomposition. Because this is the first time doing this in grade 12, I'm going to go really slow. But if factoring is something that you're struggling with, make sure you're seeing me right away because we're going to be rolling pretty quick with it. I'm not going to go step by step in the future. Okay, so see me if you need help with factoring. Okay, let's look just at f of x and g of x. Starting off by stating the domains. Okay, f of x, it's a parabola. What's the domain of a parabola? All real numbers, good. Okay, so for f, your domain will be x is an element. Actually, let's do this in interval notation. Just to review that. So we go from negative infinity to infinity. Okay, that's for f of x. And for g of x,
Caleb McGurk to the office, please.
g of x is 2x plus 1, straight line. All real numbers, good. So again, going from negative infinity to infinity. Part B, we're going to divide f of x divided by g of x. So we get 2x squared minus 13x minus 7 all over 2x plus 1. So before we can cancel out, we need to factor this. So like I said, I'm going to factor by decomposition on the side. Just as review. So we're factoring 2x squared minus 13x minus 7. We need two numbers that multiply to our a times c. So 2 times negative 7, negative 14. And those same, the same two numbers need to add to negative 13. Good, negative 14, positive 1. What we're going to do with those two numbers is break up the middle term. So this negative 13x is going to break up. We're going to rewrite 2x squared. We're going to rewrite negative 7 on the end. And instead of negative 13x, we're going to use negative 14 and 1x to break it up. Okay, so I'm going to decide to put the 14 with the negative 7 and the positive 1 with the 2. So we're going to go plus 1x minus 14x. That's the order I'm going to break it up. You could do it the other way, but I'm going to choose this way. Okay, now we have 4 terms, so factor by grouping. Group the first two together, group the last 2 terms together. And because we're subtracting the 14x, just put a little plus sign in between to show that we're adding those binomials. Now we just have to factor out of each group. So out of 2x squared plus x, we have a common x. And we're left with 2x plus 1. In the second group, we have a common factor of negative 7. So if we factor that out, we're left with, again, 2x plus 1. So whenever you're factoring by decomposition or factoring by grouping, the goal is to have common binomials, because that's what we have to factor out next. So 2x plus 1 factored into the first group leaves us with x, and 2x plus 1 factored out of the second group leaves us with negative 7. So now we factored that trinomial. Any questions? Easy review then? Like I said, if you need some help with factoring, just come see me. Okay, so instead of 2x squared minus 13x minus 7, we are going to replace that with 2x plus 1 times x minus 7 and divide by g of x, which was 2x plus 1. Before I cancel out, state your restrictions. So from the binomial in the denominator, x cannot equal negative 1 over 2. Then we can cancel out 2x plus 1, and we're left with x minus 7. So we have a restriction in the domain, but they're asking us to actually state the domain. So we would write that like this. Okay, for all the x values of x minus 7, x cannot equal negative 1 over 2, and all the other numbers will be real. So we've talked briefly about part C in the last question. If we have to calculate f divided by g of 3, in this case we've already simplified it to x minus 7. So it's probably easiest to just sub 3 into this x. Okay, so let's just do that. Remember, we reduced f divided by g of x to equal x minus 7. So if we're evaluating x is 3, you just replace the x's with 3's, and we're left with negative 4. Jackson, what's the other way I could calculate it?
Go through the whole thing again?
You don't really have to go through the whole thing again, but you can go back to step 1. So we wrote f of x divided by g of x. Instead of having the x's though, what would they be?
3.
Yeah, so if I put 3 and 3 here, all these x's would turn into 3's. Now given that we've already simplified it, would you guys rather calculate this or 3 minus 7? Probably 3 minus 7. So if you can save time, worthwhile. Okay, next up, it's a bit of review, which will be good for your quiz tomorrow. We're going back to the product of two functions. And then the next one is adding, or the sum of two functions. Alright, so f of x is given as the rational expression 2x over x minus 1, and g of x is given as x over x minus 3. We're going to state the domains. So without even graphing, let's take a look at f of x. To start, is there a restriction on the denominator? Ben, what do you got for a restriction on f of x?
1.
Okay, good. So the domain is that x cannot equal 1, and everything else is a set of real numbers. Okay, and then for g of x it's similar, but we have a restriction of 3 this time. Bless you. So x cannot equal 3, and and all the other graph numbers will be real. So if we take a look at the notation 3 times fg of 2, there's a bit of an easier way to look at that. You can go 3 times f evaluated at 2 times g of 2. So anytime you see an x in f of x, we're going to place a 2 there instead. Anytime we see an x in g of x, now g of 2, the x's will be 2. Okay, so basically replace the x's with 2. So we have 3 multiplied by our f of x, which was 2x. The x's are now 2's. So we have 2 times 2 divided by x again, replaced by a 2, minus 1. G of x is now going to be g of 2. So anytime you see an x, sub in a 2. So we get 2 divided by 2 minus 3. If you guys could help me out, what do we calculate there? Negative 24?
Yeah.
Yeah. Good. Any questions about that one? Xander, you alright? Okay, thanks Chris. Next one, write an expression in simplest form for f of x plus g of x, and then state any restrictions on x. So f of x plus g of x. Again, to sub in the functions, so f of x is 2x over x minus 1. And we're going to add that to g of x, which is x over x minus 3. So hopefully you guys can remember this from grade 11, but we're adding rational expressions. You can only add fractions, essentially, if you have common denominators. Are these common denominators? No. Okay, so step 1, basically, you're going to state f of x plus g of x. Step 2, you're going to determine the lowest common denominator, or LCD. And in this case, what would our LCD be? Perfect, Brandon. So you're going to have x minus 1 times x minus 3. So whatever is missing in the denominator of one term, you're going to have to multiply in both the denominator and numerator. So that's the next step. Multiply by the missing term, or maybe I'll say factor, of the LCD in both the numerator and denominator. And we'll just explain that a little bit more. So this denominator, it's missing the x minus 3. So I can't just go and multiply an x minus 3 in the denominator. I have to undo it by also multiplying that in the numerator. Similarly, this denominator is missing the x minus 1 from the LCD. So whatever I multiply in the denominator, multiply up in the numerator. So now we have common denominators, and step 4, we basically just expand the numerator and simplify. So this is just all review from grade 11 right now. The only thing that's different is the function notation. Okay, so our denominator will be your LCD, x minus 1 over x minus 3 multiplied by x minus 3. And let's just expand. 2x times x, 2x squared. 2x times negative 3, negative 6x. Moving over to the second term, x times x is x squared. We add that. And then x times negative 1 is negative x. So we've expanded the numerators. Now we just have to combine like terms and simplify. Okay, so 2x squared plus x squared, we get 3x squared. And then negative 6x minus another x is negative 7x. All over our LCD, x minus 1 times x minus 3. So step 5 is we're going to factor and cancel out if possible. But if we look at the numerator, if we factor an x, are we going to get anything in common that would cancel out the denominators? No, so we can just stop. The only thing that we have to do is state our restrictions and then we're done. Okay, so in here also don't forget about your non-permissible values. So from this denominator, x minus 1, we have x cannot equal 1, and from here, x cannot equal 3. So those are our restrictions. This is the expression that remains. We got one more question, and you guys are in the clear. Okay, so if I just rewrite f of x, that was 2x over x minus 1. And g of x was x over x minus 3. Is that correct? Okay, so for part D, we have to write an expression in simplest form. Basically, we're taking the quotient f of x divided by g of x, and then stating our restrictions. So instead of writing it this divided by this on top of each other, I find it's easier to write it side by side. So 2x divided by x minus 1 will be divided by g of x, which is x divided by x minus 3. So step 1, just write out f of x divided by g of x. Now step 2 and 3 can be interchangeable. You could, because it's already factored, you could take your MPV now, or you could take it after. I'm just going to do kiss and flip first, and then we'll talk about taking your MPV. So another word for kiss and flip is multiply by the reciprocal. Okay, or kiss and flip. So with kiss and flip, you rewrite the first rational expression f of x, 2x divided by x minus 1. Kiss is just multiply. But instead of an x, because we have so many x's, I'm going to put a little solid dot to show multiply. And the flip is multiplied by the reciprocal, so you're just going to flip these two, the numerator and the denominator, so that you get x minus 3 up top, and x is now in the denominator. Step 3 will be taking your restrictions on the domain, or the MPVs, non-permissible values. And I like to say that you take them from the boot. So when you're dividing a rational expression by a rational expression, I'll just draw a little boot here. It's not a nice one, but it is a boot. Okay, if the original statement, f of x divided by g of x, what are the restrictions in these denominators? X cannot equal?
1,
X cannot equal?
3.
So x can equal 1 and 3. But now that we've multiplied by the reciprocal, do we have a new denominator?
Yes.
Yeah, what can x not equal here?
0.
0, you guys got it. Okay, so x cannot equal 1, 3, and 0. So if you can remember the boot on these, that will help with restrictions. Could I have taken the restrictions from step 1? Yeah, because nothing canceled out yet. So just ignoring the boot, can I cancel anything out? Keeping in mind that this is a binomial, it's together, you can't break it up. This is a binomial, you can't break it up. Getting a lot of no's, but I'm going to tell you, there is something I can cancel out.
X.
Good, x is the common term that can be cancelled out. So you're left with 2 times x minus 3 divided by x minus 1. And we can't cancel anything out further. Now the other class, they said, well, there's 2 x's. Shouldn't there still be an x left there? But no, that only works if you have an x squared divided by x. Because that's like saying x times x divided by x. These cancel out to get 1 times x. That's the only way you're going to have x left. Okay, I forgot to write step 4. Basically, you just cancel out common terms.
We distribute the 2.
You could leave it in factored form. Yeah.
Sweet rash,
So any questions from this lesson?
these ones
You can see good?